Hello, students. Okay, so yesterday you were supposed to focus on nuclear decay. Nuclear decay. The nucleus is falling apart. Nuclear decay. Our understanding of it started with Henry Becquerel, and he was experimenting with uranium. And he noticed that it was leaving behind these imprints on film plates, so he knew there was energy coming out of them. And then he shared that with the Curies, Pierre and Marie Curie, and so they continued the research, and Marie Curie basically coined the phrase radioactive. She said that they're emitting radiation, therefore the nucleus is radioactive, and some elements are radioactive. So she coined the phrase, I guess, radioactive. So the nuclear decay is the process of the nucleus of an atom breaking down and giving off energy. I told you to draw and label everything on those because you need to know that the alpha particle gives off the biggest chunk and is the biggest change in the element, because if you change the number of protons, you've changed the identity of the element. So on that page, the alpha particle started out as a fluorine, and which has an atomic number of 9, and when it emitted 2 protons and 2 neutrons, which are a helium, because helium is element 2, atomic number 2. It emitted the alpha particle, which is a helium nucleus. And so now the new nucleus, what was left behind, is actually going to be nitrogen. It's no longer fluorine because it has 2 less protons. Also 2 less neutrons, but 2 less protons. Okay? Beta decay has 1 fewer neutron, but it now has 1 more proton. So it also changed its identity. It went from fluorine with 9 protons to neon with 10 protons. The beta particle that was given off is not a nucleus. It's a beta particle. And then the gamma decay, it's no change in the proton, so it's not a change. It's not a change in the actual nucleus, but it gave off gamma radiation. It gave off energy. Okay? Make sure you understand those, alpha, beta, gamma. The Quizlet for Chapter 2, Lesson 2 is a good review for all the terms, and you need to look at the Quizlet for Chapter 2, Lesson 1, because it's been a while since we talked about Aristotle and Democritus and Dalton and Thomson and Rutherford, and you need to know all them. Okay? So I'm going to go over the answers to the homework for you. On page 71, 1 through 9, the answers, the number of protons in an atom of an element is its atomic number. Number 2, nuclear decay occurs when an unstable atomic nucleus changes into another nucleus by emitting radiation. So those are all forms of radiation, alpha, beta, gamma. Okay. Number 3, describe how 2 isotopes of nitrogen differ from 2 nitrogen ions. Okay, isotopes, you have a change in number of neutrons, which changes the mass. Ions, you have a change in the number of electrons, which changes the neutral atom to a charged atom. Ion means it's a charged particle. We'll hit that harder when we go into chemical bonding. 4, an element's average atomic mass is calculated using masses of its isotopes. We did that in that isotope lab with the jelly beans. Number 5, compare and contrast oxygen 16 and oxygen 17. Oxygen 17 has 1 more neutron, making the mass of the nucleus 1 more. Okay. Number 6, show what happens to the electrons of a neutral calcium atom when it is changed into a calcium ion with a positive 2 charge. Calcium had to lose 2 electrons in order for the protons to outnumber the electrons. We didn't spend much time on that. And honestly, I don't think I'll double check, I don't think there's a question on this test. We're going to hit that when we talk about bonds, because that's what creates the bond, is the electrons. Okay. Number 7, copy and fill in this graphic organizer. Okay, how is each produced? So then you go up to the top. How do you produce different elements? You change the number of protons. How do you produce different isotopes? You change the number of neutrons. How do you produce different ions? You change the number of electrons. That's all that one was. Okay. Number 8, find 2 neighboring elements on the periodic table whose positions would be reversed if they were arranged by atomic mass instead of atomic number. Let's see, there's tellurium and iodine right off the top of my head. I think fermium and Einstein and on the bottom row are that way as well. So. And then number 9, can an isotope also be an ion? Yes. You can have an isotope of fluorine, and when fluorine bonds with something, it takes in an extra electron, so it becomes a negatively charged ion, but it's still an isotope of fluorine. It didn't change the nucleus. So yes. All right, so in class today, we're going to be doing page 75, the study guide. We're also going to be playing some Quizlets, both lesson 1 and lesson 2. So make sure if you're at home that you look at those and practice those, because they will help you on the test. The test is Tuesday. It'll be 35 questions, 5 points apiece. Learn Smart is due that morning before you take the test. Learn Smart is worth 100 points, so it'll be based on how much you get done. So if you get 100% done, you get 100 points. If you get 85% done, you get 85 out of 100. All right? In class, they're going to do the study guide on page 75. Remember that that's an interactive concept map, so go into your resources on your online textbook, find the interactive concept map, and mess with it before you do it on paper. Okay? Mess with it before you do it. I'm not taking a grade on it, but it'll be so helpful if you do it, because you're going to be taking a test on Tuesday. Okay? All right. So I will push out the answers, I suppose, maybe, or Monday I'll tell you the answers, or at the end of the day maybe I'll tell you the answers to 1 through 6, or I guess reach out to me if you have questions. How about that? Reach out to me if you have questions for 1 through 6. The answers to 7 through 15 are in your book on the resources in the interactive concept map. You have access to it. Do it first, then see how you did. All right? Okay. Have a great day. Have a good weekend.